Welcome to the Interval 0 video on the RTX64 MSpaces tool, available in RTX64 4.0 and later. In this video, we review the local memory allocation spaces in RTX64 and show how to use the RTX64 MSpaces tool and interpret its output. First, we'll review the local memory allocation architecture. In RTX64, you can choose to request memory from the local memory pool. You can configure this and other memory allocation behaviors in the RTX64 control panel on the Manage Memory page. Local memory includes multiple separate internal and external memory allocation spaces called MSpaces. When you request to use local memory, the subsystem configures all RTSS applications to request memory from their local memory MSpaces. Local memory is deterministic, with one exception: when an MSpace is configured to auto-expand and that MSpace lacks sufficient available memory to satisfy an allocation request, it will expand. This expansion is non-deterministic. The RTX64 subsystem, network abstraction layer, and RTTCP IP stack, along with each RTSS process and Windows proxy process, each has an internal MSpace for internal objects and bookkeeping, and an external MSpace for process-explicit allocations. Memory allocation requests from real-time APIs, including from C runtime libs, are allocated within the external allocation space. Memory requests from the subsystem for internal objects are allocated within the internal allocation space. Memory is allocated from one of the process MSpaces unless the memory is required to remain over process exit, such as memory for IPC objects and cross-process shared memory. Such allocations are made from the subsystem's MSpaces. This diagram depicts memory allocation for an RTSS process or system process from the Windows non-paged pool to the external and internal MSpaces. We discuss this in greater detail in the memory allocation overview video available at interval0.com. Here we can see the allocation spaces for various types of memory requests. You can see this table along with more detailed information on allocation spaces in the RTX64 product help. The RTX64 MSpaces tool was introduced in RTX64 4.0. It's a command line tool that shows information on all existing memory allocations for the subsystem, networking components, and each real-time process. It also provides helpful information on MSpace fragmentation and memory layout. Here we have the project source for a real-time application open in Visual Studio. This particular project includes memory allocation requests from the process external and internal MSpaces and the system external and internal MSpaces. If we run this application and then run the RTX64 MSpaces tool, we can see memory usage information in the tool's output that corresponds to the memory allocation requests in the application project code. Note that the allocation amounts highlighted in the RTX64 MSpaces output are slightly larger than the amount of memory allocated by the application. This is because the C and C++ runtime libraries also allocate some memory for their own use. It's also worth noting that the values in the RTX64 MSpaces output will change due to fragmentation if you perform multiple allocations. We can now compare memory allocations in the project source with the corresponding output from the RTX64 MSpaces tool. All C and C++ runtime library APIs allocate memory from the process external MSpace. These two calls, one to malloc and another to new, which uses malloc, allocate 40 megabytes combined from the process external MSpace. In the RTX64 MSpaces output, the current usage value for the process external MSpace includes the 40 megabytes allocated by the malloc and new calls in our application, as well as memory allocations for all C and C++ runtime library APIs. This code calls the function createThread 3 times to create 3 threads. The memory for these threads is allocated from the process internal MSpace. In the process internal MSpace section of the output, we can see the memory allocated by the same 3 threads created by the application. This call to RT-create shared memory allocates 30 megabytes of memory from the system external MSpace. This allocation appears in the RTX64 MSpaces output under current usage information for the system external MSpace. Next, we can see a code block that calls real-time API RT-create event 4 times to create 4 real-time event objects. The memory for these objects is allocated from the system internal MSpace. The system internal MSpace output shows memory usage for these 4 real-time event objects. The RTX64 MSpaces tool can also display MSpace summary information and memory fragmentations within the MSpace as a whole, or separately within an MSpace's local pool and pool cache. You can sort fragmentation data in ascending order by range start address using the command line parameters /s or /sort. This information can help you identify possible memory leaks, among other issues. Note that it may take several minutes for sorting results to display depending on the number of fragmentations. See the RTX64 MSpaces topic in the RTX64 help for information on the different fragmentation types. This concludes our look at the RTX64 MSpaces tool. For more information, see the documentation installed with the product and available online, and check out our other product videos available from intervalzero.com and YouTube. Thanks for watching!